We're going on now to topic 3 of chapter 5, polynomial equations and factoring. We'll talk about graphical solutions, the principle of zero products, terms with common factors, factor by grouping, factoring, and equations. So there's lots of different things tucked into this one section. So let's move it up a little bit, and we'll do our key terms here. We have 6 of them. All right, our usual technique, we'll pause and then go over them. Now, as we go on to number 1, I'd like to spend a little time because this is a good review as well. A value for which the function f of x is 0. Now here they're saying f of x equals 0. Now, what did we say f of x could replace? Well, a y. So in a sense, we're saying y equals 0. Now, when you have something like this, and it's quite obvious from what they're showing here, so the function of x is 0. Y equals 0. This is then called 0 of the function. Now, if you were to make a t-chart with this, and your f of x is here, remember that's y, this value would be a 0. And in many cases, there's more than one 0. So this is sometimes referred to as finding the zeros. And that's what it refers to. Now in number 2, the x value for which a function is this is called the root of the equation. So root is a synonym for solution. And we'll show you some examples of this as we go on. In number 3, the principle of zero products state when you have two factors like a times b equals 0, this is only true if either a or b is a 0. The only way you're going to get a product that is 0 is if one of the factors are 0. And this is called the principle of zero product. To write a product in order to sort of work backwards, if you end up with a product, what did you have leading into that? Well, you had factors. So the factors, as we have here, a times b, these are factors. 0 is the product. When a polynomial is written as a product, the product is called factorization of the polynomial. So we'll see examples of that. What do we mean by factorization? Well, a very simple example would be if you had the number 6. Now 6 is the product. What were the factors? Well, 2 times 3 were a common set. So these would be factorization of 6. And number 6, this is when factoring a polynomial, what do we always do first? Well, we factor out the greatest, sometimes referred to as a capital G, common, capital C, factor, capital F. So you'll see these initials every once in a while. Greatest common factor. Well, they're starting us right off. It says use the graph to solve f of x equals 0. Now remember, we said that we could replace this with a y equals 0. Where does y equal 0? Now y equals 0 there and there. So I have two places where y, again the y-axis, that we have zeros. So there are my two zeros. And then here, our x value would be 0. And here, our x value would be 3. So when we use this graph to find the zeros, we're thinking y equals 0 up over here. And this is the way we do it. So another example in finding the zeros. So there's our graph. And where is y a 0? Well, it's a 0 there and a 0 there. So I've set it up. So what will the x values be? Well, the x value here is a -4. And there, a +2. Now remember, these are ordered pairs, but we're particularly looking for our x values because we're saying find the zeros. Okay, in number 9, it's a little different. They're not asking us to find the zeros here, but here they're telling us that g of x is 5. Well, remember, g of x could be y equals 5. Well, if y equals 5, as I have here in our little t-chart, what will the x values be? Well, over here, the x value is going to be a -2. And over here, it's going to be a +2. So the solution, it says we're using this graph, which is this parabola, but they want us to find when g of x, which is y, equals 5. So there's our 5s, and we want to find our x values. So the answer to number 9 is -2 and 2. Here they're giving us lots of examples. So for number 10, here they want us to find the zeros of this parabola. There's the graph of the parabola. We're looking for where the graph crosses the x-axis, because there our y value is 0. So finding the zeros is where the parabola or the line crosses the x-axis. In a sense, they're the x-intercepts. And there they are. Now, for all of these, they're using a graphing calculator, which we don't use. So we will be skipping 11 through 15. We'll show you how to do this manually in a few moments. We'll get back to finding the zeros, which is sort of an exciting thing here, in a little while. Right now, we're going to start doing some factoring out the greatest common factor. So as we look at this, we see we have a what factor in each term that we can factor out. And the answer is a 2. We'll factor out a 2. Then we'll see what we get. Here we can factor out an x to the 3rd out of each of these factors. Here we can factor out a 4t². And then here we can factor out a 2 x, y out of each term. And we'll see what you get in there after we've given you this hint. Well, take a look and see how you did. Now, notice that inside the parenthesis, there are no more common factors. If we achieve that, then we are successful. And notice you can always check your work by distributing. Now, an interesting thing over here in number 18, that sometimes students will take out a x to the third okay, but then they won't put the 1 there. Now that 1 is important because it's x plus 1. If you just had an x, you wouldn't get this term again if you distribute it. So distributing is a good way to check your work. Now as we do these next few examples, you want to develop a protocol. So you're looking at this, you want to factor out the greatest common factor. And then you're going to have a parenthesis for 3 terms. So the greatest common factor here is what? A 7. Now here we have a 15, a 10, and a 25. So for the number part, the greatest common factor will be a 5. We can take a 5 out of each one. Now here we have x to the 5th, x to the 2nd, x to the 3rd. So the greatest common factor we could take out of the x's would be x to the 2nd. And then the y to the 1st here. Looks like we can take a y out of each term. And then z to the 4th is the largest we can take out. And then now in 23 and 24, they want us to write an equivalent expression by factoring out a factor with a negative coefficient. So here we're going to factor out a negative 10. And here we can take a 6 out of each term. So it would be a negative 6. And I guess that's as far as we can go. There's no letter that's common. Okay, so let's complete this. You can check your answers. And notice you can distribute to see if in fact you get what you started with. This technique down here is particularly useful in later chapters where you have to take a negative something out so that what you get in your parenthesis is what you're looking for. And you'll see that as we go on. Now in these next two, we see here in 25, there is a common C, but we want to take out a negative 3. So this is going to be a negative A, and this is going to be a positive B that's left. Now notice if you distribute, you get here a positive 3A, and here you get a negative 3B. So you've taken out a negative from each of these and a common factor. Now for number 26, there is no common factor, but they did say they wanted an equivalent expression where you factored out a negative. So we can factor a -1 in a sense out of each of these, and it just changes all the signs. So this now becomes t to the fourth plus t to the third, but now opposite sign, minus 2t minus 13. So again, some useful techniques of doing something. And we had done this earlier when we took a negative in front of a parenthesis, removed the parenthesis, and then just changed all the signs. So we're sort of undoing what we had done. A good technique to be familiar with. Now, let's see what we have here. Okay, that's better. Now, as we look at what we have here, write an equivalent expression by factoring. Well, what common factors do we have? Well, here, this is a common factor in each one. And if you recall from the previous lesson, we said we could factor these out. And I will, right here. So this is y plus 2. And then in another set of parentheses, I'm going to put the x plus the z. Now, what we did is we had a binomial times a binomial. We said we would take the first member of the binomial and multiply it by the second binomial, which is what we had here. Then the second member of the first binomial, multiply it by the second binomial, which is what we had here. So we've just reversed that step. And this is a major thing to do. Now, sometimes the factor could be in front, like this. So what we have here, this one's a little tricky. Now there's our common factor, and then it would be this plus this, which is sort of that style up here. And here we just combine like terms, and that is our answer. We won't be doing any of this level in our class. That's a little more advanced. Now, number 29 is a little tricky because what's going on here? Here we have t minus 1, and here we have 1 minus t. In order to get that to be something we have a common factor in, I'm going to rewrite it. Now, I can reverse these signs by taking out a negative. And it'll be a -5 out there, changing that sign. And then this becomes t minus 1. So that's the tricky part right there. These are not the same, but if I take a negative out of this and reverse them, it becomes the same. And that negative that I took out is applied to the 5. So I now have the t minus 1, and then in my other parenthesis I put 6t cubed minus 5. Now if you wrote the t minus 1 first, that'd be okay. All right, this introduces us to our next little part here, which is called factoring by grouping. So we look at our expression, And we see that in this one, there is a common v. So I can pull that v out. And I'm then left with a u plus w. Now here I see a common t. So I'm going to factor that out, and I get t, and I get a u plus w left. Now notice I have a u plus w, u plus w. I can now pull that out, u plus w, and I have now a v plus my t there, and that is factored by grouping. All right, I'll let you try the next few, and I'll do them as well. So in number 31, I can factor out an x squared here. Get this. But now notice the signs don't line up. But if I factor out a -2 from each of these, as we had some practice with, I end up with a common factor. So this would go in one parenthesis, and this would go in the other. As I get to 32, I can factor out an m squared, but nothing else. So we say that no factoring by grouping can go on here. We can't do anything with that. All right, in number 33, there's a lot going on. First, notice there's an a term in every one, and these are sort of out of order for descending. So I'm going to switch these two around and then factor out an a squared from each term. I then get this. Now from the first two here, I'm going to factor out an a squared, and I get this. And now that I've switched these around, I can factor out a 5 here and get this. So what's my final answer? Well, it will be a squared. Then I'm going to have two sets of parentheses. And then in this one, I like to put what I get here. And then in this one, I'm going to take that a squared and my plus 5. And that is the answer. Now, as we look at this one, I'm going to study that a moment. Now, every once in a while, you have to fiddle with the order of what's in your expression. So these are very challenging sometimes, and again, some of these go beyond what we are going to do in our introductory course. But just to show you this one, I had to rearrange. I put the 20 there, and then everything seemed to work out. I could factor out a 5, and then here I'm factoring out a -p, and then I get my common factors here, and that's that. We've skipped a couple, but I want to take you to this next part, which is going to be very, very important. Now you recall way back in the beginning, we had seen something like this, that a times b equals 0. And if you recall, we said that was the principle of zero products. In order for this statement to be true, either the a or the b had to be 0. So here we have something a little more complicated where we have this factor, and they're saying it equals 0. Well, how do we solve that? Well, we solve it by setting up two little equations. We take the first factor, 3x, and equal it to 0. We're saying that 3x could be 0. Or x minus 9 could equal 0. And here, when we solve, dividing both sides by 3, we got x equals 0. And here we just transpose that, and we get x equals 9. So we are solving this little equation using the principle of zero products, and there are our two solutions. Now, for this one, we have to take out the greatest common factor here, which is going to be x. We factor out the x, and we're left with x plus 12. And they're saying that that equals 0. Well, we then use that same technique, x equals 0, or, and in your notes I'd like to see this pattern, x plus 12 equals 0. So there's one answer already, x equals 0, and here x equals a negative 12. We just transpose that. And actually, these are our answers. And again, we're using the principle of zero product. Now, for this one, again, we like to keep them positive. So let's transpose this to this side. This side will then be a 0. This will become 12x squared plus 24. And what we're going to do on this side is factor out a 12x. Forgot to put that one there. And then this becomes x plus 2. We now have two factors. I'm going to put them up here so we don't run out of room. It'll be 12x equals 0, or x plus 2 equals 0. Again, we're using that principle of zero products. Divide both sides by 12, x equals 0. Here we just transpose, x equals negative 2. Those are our answers. Now, in keeping up with our tradition of function notation, here we're saying that f of x is this. But what did we say f of x could replace? Well, it could be a y. And here they're saying that y is equal to 0. So this is just the function way of showing that negative 6, let me put the right numbers here anyway, that negative 5x times x plus 3 equals 0. This is just another way of, say, finding the zeros. So we equate that to 0. Negative 5x equals 0, or x plus 3 equals 0. Again, my pen's not working too good. So here we're dividing both sides by a negative 5, and we get x equals 0. Here we just transpose the 3, and we get x equals negative 3. They make it a little complicated, but they want you to be prepared for the Math 105, where you will be dealing with functions a lot. So just remember this is y, and they're telling you y is 0. So this is what it becomes. And then we use the principle of zero products. Okay, this wraps up this section. Again, try to stay current with your practice and quiz me's.